Okay, so in this video we're gonna talk more about finding intercepts of polynomial functions. So this is kind of review. It's just that we talk about these intercepts as zeros, as roots. So we're just going to look at a couple of different things, but we're going to remember that to find an x-intercept that we need to set y equals to 0, which is the same as f of x equal to 0. And then we're going to use some polynomial factoring techniques. And remember the zero product property. So zero product property, it's basically if we have 0 on one side and we have factors on the other, at least one of those factors has to be 0, right? And so obviously if we're talking about factors, we would want to review the steps of factoring. So that is there for you. And then if we cannot factor, we could use the quadratic formula if we do have a quadratic or if we have something in quadratic form. Okay, so let's try one of these. Okay, so you can see here that this is a sum of cubes. What we're going to do is we're going to set f of x equal to 0. So we're just going to say, when is this going to be 0? Because that's what where the x-intercepts are happening. And to factor this, we would use SOAP, same, opposite, always positive. So this is, oops, darn it. This would be the same, opposite, and then always positive. There's your signs. And then we'll use one of each. X makes x cubed, and 4 cubed is 64. So we're going to go x and then 4. And then we'll go x squared, and then 4 squared, which is 16. And then just 4 times x in the middle. Okay. We can always erase this part. Let's see. Okay. All right. So now we have our two factors, and their product is equal to 0. So that's only going to happen if x plus 4 is equal to 0, or if x squared minus 4x plus 16 is equal to 0. Okay. So remembering that we're trying to find x-intercepts, which means that it has to be in the coordinate plane, which are all real numbers. So when we subtract 4, x equals -4, well, that's definitely a real number. So the first x-intercept would be -4 would make a 0. Okay. The next one, if you are factoring cubes, that second factor is not going to be able to be factored further down. We would have to use the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac and over 2a. Now, if we look at this, we can see that this number right here is definitely going to be negative. And if we have a negative number under the radical, then this is going to be a complex number, which is not in the, it is not a real number. So that means it is not going to give us an x-intercept. So right now we only have one x-intercept for this graph. Okay, let's look at this one. So this one has degree 4. So in order to even factor this or use quadratic formula, it has to be in quadratic form. So we've already done this in the past. We're going to take this and set that equal to w so that we can see this problem in quadratic form. So we'll have 0 is equal to w squared minus 10 times w plus 9. Now we know how to factor that. We would say w minus 9, w minus 1, and we would say w minus 9 is equal to 0, and then w minus 1 is equal to 0, and we would solve. Now this is all great, but we didn't need w, right? Add 1, add 1. We needed x. So now we are going to go up here and take this w equals x squared and substitute the x squared back in. So when we do that, we can take the square root of both sides, but we put plus or minus. So this is x is equal to 3, x is equal to -3. And we do the same thing on the side. And we get x is equal to 1 and x is equal to -1. So those are all the x values that would make y 0. So that means these are all intercepts. So we would have 3, 0, -3, 0, 1, 0, and -1, 0. So those are the intercepts for this graph. So once we have the intercepts, we can help form the graph a little bit better. Okay, this one is a little bit different because, well, first of all, we'll put 0 on one side. But we're going to notice that there's an x in all of these terms. So we're going to actually factor an x out first. X squared minus 14x plus 13. And then we can keep factoring. So we'll still have the x, but we'll have x minus 13, x minus 1, because two things that multiply to positive 13 and add to a negative 13 would be negative 13 and -1. And so we have this is equal to 0, which means that each factor could be 0. That product only happens to be 0 when either x is 0, x minus 13 is 0, or x minus 1 is 0. So x equals 0 just gives me the x-intercept 0, 0. On this one, we'll add 13, and we'll get x is equal to 13. So that will give us 13 will make a 0. And then adding 1, we would get that x is equal to 1. So we would have that 1 equals a 0. And so for the next problem, and we're going to first get that 0, right? Because we're trying to find out what would make the function 0. And we see that this has 4 terms. And so we're going to practice factoring again. And when we factor 4 terms, we factor by grouping first. So we can see how that we have an x cubed in common here, and we'll get x plus 1. And there's nothing in common, so it's like having a 1, x plus 1. And then both groups have an x plus 1, and we're left with an x cubed plus 1. Well, this x cubed plus 1 can go further. So we still have the x plus 1, and we're going to use our pattern for factoring cubes. Same sign, opposite sign, always positive. 1 of each, squared of each, and then 1 of each. So 1 times x is just x. Okay, so now what you could find interesting is that these are the same factors. And so we're only going to get one x-intercept out of that, but we'll talk about that later. It'll be multiplicity 2. So this guy will give us a -1, 0. And then the last factor came from the sum of cubes. So we did talk about that, but if we go to find the 0 or x-intercept for this, we would do the opposite of b, which is a positive 1 plus or minus 1 squared minus 4ac all over 2a. And guys, this right here is going to be negative. And so when we have a negative under the square root, it's not going to be a real number. So the only x-intercept that we have for this graph is -1, 0. And we will be talking about how that had multiplicity too when we graph. Okay, I hope that helped. Take care.